How are you, my friends? This is another video in the basic math terms, and this is a continuation of the videos for Calculus 1 terms. Just to remind you that part 30 was the start for Calculus 1 terms. If you want to see the algebra terms, you can refer to parts 1 to 18, already on the playlist. And if you need any term in the pre-calculus terms, you can refer to parts 19 to 27, please. And for statistics terms, you can go to parts 28 and 29. Now, this video is about maxima and minima, part 35 in the Calculus 1 terms. We will see the maximum definition from dictionary, the minimum definition from dictionary, maxima, minima, local, relative, extremum, extrema, absolute, global, critical values, critical points. Let's start with the definition of a maximum. A maximum, you can see it in the dictionary, is the utmost or the ultimate or the highest or the topmost, superior or greatest, and many other synonyms. One example, we can say he got the maximum grade in the math test. Or we can have another example, if you like. The parabola has the vertex as the highest point in the graph. A minimum is the lower, minimal, least or lesser, down or low, and many other synonyms. Example, this can be done with the minimum amount of effort. So that's maximum and minimum. Now we go to the maxima, which is the plural of maximum. If we have more than one maximum, we say maxima. In some graphs, you can find more than one maximum. Minima is the plural of minimum. In this graph, you can see here more than one minimum, more than one maximum. See, there's a graph here between A and B. There is a max here, there is a max there, and there is a max there. I will explain in details now. There is a minimum here, there is a minimum here, and there is a minimum here. Each one is different. Now let's go to local. Local means domestic or regional. Local. Relative means comparative or specific. Now in mathematics, this is from the dictionary, the first two lines. In mathematics, we say the word local maximum means relative maximum, so the same meaning. The word local minimum means relative minimum. Now local extremum, this is a singular, so that's one, is either local maximum or local minimum. So if we have local maximum or local minimum, we call it local extremum. Local extrema is the plural of local extremum. If we have more than one local or relative extremum. See, here we have local, see this now, local maximum, local maximum, local maximum. This is local minimum or local minimum, or relative minimum and relative maximum. Let's see more terms. Absolute maximum, the same meaning as global maximum, which is the largest value of all local maxima. Absolute maximum is global maximum, the largest value of all local maxima. Absolute minimum, the global minimum, the same meaning, the smallest value of all local minima. So if we have a graph like this, this is the highest, the largest. So this is the absolute max. We say global max. And this is the absolute min or global min. This is the smallest in all the minima. This is local minima, still local or relative minima. This is local minimum. and this is local max, and this is local max, but the highest will be absolute max or global max. Now the number C in the domain of a function, we call it critical number if either f prime of C is equal to 0 or f prime of C does not exist. This is the critical number. Now the point itself, C, when you find C, find the image of C, replace C in the function. C, comma, f of C, that's a point. This point is called critical point, and the other value of C or X, we call it critical number. One nice example on maximum minimum, just to show you the idea here, find the maximum minimum values of this function, polynomial function of degree 4. 1 over 4 x to the power 4 minus 1 over 3 x cubed minus 3 x squared minus 20 on the closed interval minus 4 to 2. This is really nice question. So we can start by the derivative of this function f prime of x. It will be bring 4 down times 1 over 4, so it will be x cubed minus bring 3 down here and subtract 1, it will be minus x squared minus 6x. The derivative of minus 20 is 0. So this is f prime. Put f prime is equal to 0 to find the critical numbers. So solve the equation x cubed minus x squared minus 6x is equal to 0. Take x as a common factor. Inside we have x squared minus x minus 6, and we can easily factor this trinomial. So this is x minus 3, x plus 2. So we have 3 critical numbers, x equals minus 2, x equals 0, x equals to 3. Now we notice here that the value x equal to 3 is not in the given domain. See, 3 is outside minus 4 to 2. So we can accept only minus 2 and also 0. And we have also the endpoints of the interval, minus 4 and 2. So this, we call this the checklist, minus 4, minus 2, 0, and 2. Now this is the nice graph you will see here. So we have 4 points here, 4 numbers, minus 4, minus 2, 0, and 2. Each one, we will replace it in the function. So we need to get, see here, f of minus 4, f of minus 2, f of 0, f of 2, 4 of them. All the list here, including the endpoints of the interval. See this one here, the red dashed is the whole graph of this function, degree 4, polynomial function of degree 4. But we need from, we need from minus 4 to 2. See, this is, we are studying here from minus 4 to 2. So we look, where is the maximum number? 17.3, which is, this is 52 over 3 after we replace minus 4 in the function. So this is the absolute max. You see this one? Absolute max. We have local max here. F of 0 is equal minus 20. This is local max. At minus 2, there is a local minimum here at minus 2. See, this is a minimum, but local. If you replace 2 in the function, you get minus 92 over 3, which is approximately minus 30.6. So that's the point, this black dot here. So this is the absolute minimum. Absolute minimum, absolute maximum, local maximum, local minimum in this interval minus 4 to 2. Now, this is one slide summary of the whole part 35. If you want, you can read here all the definitions of this local maximum, relative maximum, extremum. Remember, this is a singular. Extrema, absolute max, global max, maxima, and minima. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.